That flux is going to measure more brightness than this flux. Why is that?
Wait, let me put it this way.
Spread out isotopically. That.
Right. Stop using fancy words. Our audience is in 8th grade. Alright, so Ref, I know you're scared of this.
Okay.
This is Rashibari from Columbia University. Welcome to Daily Physics. Today our episode 13 and our topic is luminosity, flux and luminous intensity. Just like every day, we're going to give you 3 levels of understanding. I myself going to keep it high school level. I'm going to invite Shubhanu Isaac to give you undergraduate level understanding. Welcome, Shubhanu. And I'm going to invite Raf Bari to give you a graduate level understanding. Welcome, Raf. Let's start with luminosity. To understand the luminosity, we're going to use, for example, if you take a bulb and the sun, right? So the bulb brightness and sun brightness. Okay. What is the definition?
It's the intrinsic brightness of a source.
Of a source. Okay.
Intrinsic brightness of a source. At that point, just say it's brightness.
Okay.
No, because brightness.
Don't try to cope your not understanding in fancy, dense words. Just say, I don't know what it is, but I'm going to guess
you don't know.
Because luminosity is not the synonym of brightness.
Okay, just because you don't understand basic physical
terminology,
that doesn't mean I can't use them.
It is a light bulb. Okay, and we're going to try to understand the luminosity. What is the luminosity? The joule per second, right? So joule per second. All right. So
yes, it's the joules of electromagnetic radiation that something is emitting in total per second.
Okay. So that means the watt. So what is the SI unit for luminosity?
It's emitting light in all directions.
But
what direction you're emitting light in doesn't matter. And then you're calculating luminosity.
If someone is standing 1.5 times 10 raised to 11 meter away from the sun, that means you are standing on the earth. Okay. The brightness.
It could also mean you're standing anywhere in Earth's orbit.
Probably. So, where do you see? What do you call it? This is called flux, right?
Mm-hmm.
Which flux is going to measure more?
The one close to the sun.
Okay. So
yeah, of course.
That flux is going to measure more brightness than this flux. Why is that?
Because
wait. Let me put it this way.
Spread out isotopically. That.
Right.
Stop using fancy words. Our audience is in 8th grade. All right. So, Raf, I know you're scared of this.
Okay, I know you're specifically in 8th grade.
Yeah.
All right.
No, just try to cover your ears because I know you're scared of this one.
All right.
So you can imagine the light that the sun gives out like a shower. I'm so sorry for exposing you to that word, Ref. But you can imagine it like a shower of light instead of water. Yes, Ref, I'm sorry. I'm so sorry. So, as you can see, if you're closer to the shower head, you're going to capture more of the water because it hasn't had any time to spread out yet.
That's why I jump up when I take shower.
The sun. Whoa.
What?
And that's why, since the sun emits light the same in all directions, what Ref likes to code in fancy words like isotropically, since the sun emits the same amount of light in all directions, as it spreads out, if you're going to take a surface farther from the sun with the same area, you're going to get less light than
That's why I walk on the rooftop. That's why I walk on the rooftop.
No, walking on the rooftop increases the danger to your life significantly without giving you a more significant amount of vitamin D. At that point, might as well try to look for a job on Mount Everest.
Equation for flux. L over 4 pi r squared. Can you find the flux? What would be the...
Let's first talk about why it's L over 4 pi r squared.
Okay, so I'm going to open it for Isaac. So Isaac going to give an undergraduate explanation. Spending 2 minutes. He's going to first explain the luminosity and then flux and then luminous intensity. And then we're going to take you to the graduate student, Brown University. Isaac, you have all...
Also known as the failure at Brown University.
Okay, Isaac, you have all the attention.
To give attention to anything. Not just...
Loading ChatGPT.
ChatGPT, how do I call this guy an idiot without getting my video banned from YouTube?
By
Oh.
not calling him by calling him genius?
It's not in my capacity to lie. Okay, so first of all, my marker's dead.
So let me explain for you.
I'll give you
So let me explain for you. Okay, buddy, don't get too carried away with spreading misinformation. I know you love doing it. Okay, so luminosity.
Okay, so luminosity.
Shut the fuck up. I didn't mean to say
Okay, Pee Wee Herman.
that. Still isn't here. You! Eat my cock! Okay, that's coming too close. This I can't take it anymore. Okay, luminosity. It's just the total amount of radiation, or electromagnetic radiation to be specific, commonly known as light, that an object is giving out in joules per second. Luminosity.
Okay, yeah. What are we
Not to be
looking?
confused with luminous intensity, which, despite the name, a very stupid name in fact, it's a totally different quantity measured in totally different units than joules per second.
Whoa.
So, next, flux. Flux is not exclusive to light. There's electric flux, magnetic flux, hell, gravitational flux. You want to really get funky with it.
Oh, what are you listing?
luminosity, flux, and luminous intensity.
Oh, I see. Okay, I thought. Okay. Okay, I thought you were listing all the things you don't understand.
No, that would be you. That would be you.
Isaac, you have 2 more minutes because I have only 10 minutes. I'm sorry.
Yeah, and guess who caused only having 10 minutes?
Go ahead.
Talking about Coldplay.
Go ahead.
So it's just the measure of how much of a field is going through a specific area over time. Now, light is cool because unlike all the other funky fields, light goes in an approximately straight direction. And since we're considering a very simple case, one solitary light source from which the field is being emitted outward, the light strength is simply going to decline like any other very simple field. Because we are working in 3D and light is being emitted isotropically, is the fancy word user likes to say, then the total flux, which is just the total light per unit area, is going to be all of the light divided by the area of the sphere, the surface area. L over 4 pi r squared. Finally, let's talk about luminous intensity, which for some stupid reason, totally different than luminosity. Yes, I thought they were the same thing.
L over 4 pi.
Can you shut up? Thank you. Yes, I thought they were the same thing too until I started doing the research for this episode. So, luminous intensity depends on the stupid thing that we call a solid angle, right? So, basically, let's say you have a sphere right over here.
Isaac, 1 minute.
You look upward. Now, your field of view is small because we're humans, hopefully. Which means that since your field of view is probably, let's say, 30 degrees left, 30 degrees right. Yes, that's not the normal human field of vision, but, I'm making assumptions here. Sure, let's make it a little bit bigger. Let's make it 45 degrees left, 45 degrees right. Then, this angle right here is the solid angle. So, all luminous intensity is the light per solid angle, where solid angle is this thing over here, which is much different than light per unit area because of the funky way that solid angles and light area works. So solid angle is actually measured in a totally different unit called steradians. Also,
It's actually pronounced steradians.
I said that!
I know, I was just saying it.
it depends on the frequency or wavelength of the light. Alright, that's it. Thanks everybody for watching.
Let's start off with luminosity. Okay, well, it's not about how you spell it. Let's just write the word luminosity.
You got some severance on your mind, huh?
Okay, luminosity is about.
Do that stupid fucking bucktooth laugh again, and I'm going over to Braille myself and kicking the shindigs out of you.
Hey, who is going to run physics?
Who is going to brown physics? Who is going to brown their pants in a few minutes? You.
Okay, so let's say we have some kind of a light source. Oh, God, man. Okay, this could be the sun or a light bulb, and it emits the same way in every direction. Okay, so it emits isotropically.
And it emits the same way in every direction. They already know what isotropic
I'm gonna
means.
kill you.
You can use that word now, goddammit. God damn you.
Okay, let's use a different word. Homogeneous, okay?
Homogeneous. You don't even know how to pronounce that.
Okay. I'm going to give a graduate level understanding. So you can approximate the luminosity of the sun. Luminosity, what are the units of luminosity? The units are watts. And that means luminosity is energy per unit time. So that means if I write it in SI units, this would be joules per unit second. So if you want to approximate the luminosity of the sun, you can actually do that very easily. Luminosity is just like power. How much work do you do over time? How much energy do you over time? And the luminosity of the sun.
Are you sure this is a graduate level understanding, bro? You're copying everything I did, but worse.
The luminosity of the sun is given by a very simple equation called the Stefan-Boltzmann equation. So it depends on the surface
temperature. Did you just write death on the board in really bad handwriting?
The luminosity of the sun depends on its surface temperature, which is about 6,000 degrees Kelvin, and the surface area of the sun. So you look like a freaking gopher.
God. Yeah, that's what you look like. I'm trying to imitate you.
Isaac, he has 3 minutes. Come on.
So this is luminosity.
Okay, bye.
What was the next concept? Flux.
Flux, yeah.
Man, stupid! Yes, it was flux, and after that, luminous intensity. There, your goldfish brain got it.
Now let's talk. Now let's talk about flux. So flux, luminosity does not depend on your distance from the sun. It doesn't depend. So if you are looking at the sun from here or from here, the luminosity will stay the same. Yes. Luminosity is intrinsic brightness. Flux depends on your distance from the source. Because the source is emitting radially in all directions, that means if you imagine a sphere, imagine you have a sphere, and then you carve
You're just copying me!
Isaac, he has 2 minutes.
Okay, fine.
Yeah.
So if you carve out a sphere, imagine that you are r meters away from the sun at point A and 2r meters from the sun at point B.
Yeah.
At the second point, you will receive 4 times less light. Why? Because the flux.
Oh, that's where the 4 pi come from.
That's not where it comes from.
So, yeah, that's where the 4 comes from. So,
no, the derivation of a sphere surface area does not have anything to do with that.
No, the 4 comes from if I plug in.
So, no, the 4 comes from integration. The 4 comes from the surface area of a sphere, which comes from integration.
You didn't invent calculus. I did.
Yes, I did. So I am the reincarnation of Isaac Nan, or whatever his name was. I forgot.
So if I
Ramanujan? He invented gravity?
Okay, so if I plug in 2r over here, you can see the flux will be 1/4 of the flux at point A. So the flux at point B will be 1/4 of the flux at point A because light has to see the light is spread out over a greater surface area at point B than at point A. Yeah. So that's the idea behind flux.
Maybe you have 1 minute. Can you finish it? Isaac, please don't discuss anymore.
Okay, the final concept is luminous intensity.
Right.
So luminous intensity, the idea is simple. So the idea of luminous intensity is it's not about what is the total brightness of a source. It's about how much light is passing through a certain area. Imagine you have a flashlight.
No, that's a
Don't
radiance. That's a radiance. That's a radiance.
that's the radiance.
Debunked.
That's what I'm talking about. So
You're
the
talking about a
luminous
radiance. You're
the
not talking
luminous
about luminous intensity.
the
Debunked.
luminous intensity is the luminosity divided by 4 pi, and this has units of steradians. So that means if I have a light source at the center, the luminous intensity will tell me how much of the light is passing through one steradian. One steradian is like this solid angle. It's similar to 1 degree, but in 3 dimensions.